Today we're going to start section 4.1 and 4.2, graphing quadratic functions. First thing we need to do is write a function in standard form. In order to do this, for y equals -4 times x minus 7 squared plus 2, first what I want you to think about is the x minus 7 squared. If I were to rewrite that, it would be -4 times x minus 7 times x minus 7 plus 2. That's one of the most common mistakes, is that people don't write that out twice. Sometimes people like to just square the x and square the 7, but that's not what that means. It's x minus 7 times x minus 7. Now if I multiply that out, I would get -4 times x squared minus 14x plus 49. And that minus 14x comes from the outside and the inside of FOIL. -7x minus another 7x gives me this -14x. Now we multiply everything by that -4. So we distribute the -4, but then we still have that plus 2 hanging out at the end. So when I take 196 plus 2, that's going to leave me with the minus 194 at the end. So that would be writing it in standard form. Standard form looks like ax squared plus bx plus c. This time we have two sets of parentheses to start with. Now I would definitely take those two and FOIL them together first before we multiply by the 1/2. If you were to multiply by 1/2 first, you can only distribute that 1/2 onto one set of parentheses. But what I like to do is I like to take those double sets of parentheses and FOIL those out first. When I do that, I get the 1/2 and then x squared minus 2x minus 24. And again, the reason why I have minus 2x in the middle is because I'm taking positive 4x minus 6x, and that gets us to this minus 2x. And then always watch your signs. The minus 24 comes from -6 times positive 4. Then we distribute the 1/2 and we get y equals 1/2 x squared minus x minus 12. And now that's written in standard form. Now let's talk about graphing. The quadratic function y equals ax squared plus bx plus c. That is standard form. A cannot be 0. What makes this a quadratic function is that there actually is an x squared. So a can't be 0 because then there wouldn't be this x squared hanging out here. X squared is what makes it quadratic, and it's going to make the graph look like a parabola. If a is greater than 0, okay, so if a is positive, this graph is going to open up. So it will make an upward U shape. If a is less than 0 or negative, it's going to open down. So it will make a downwards U. The x-coordinate of the vertex is -b over 2a. Okay, get very familiar with that. -b over 2a. And then the axis of symmetry is going to be the vertical line, x equals -b over 2a. Okay, notice the -b over 2a is the same in that situation. And then the y-intercept of the graph is going to be at c. So it'll be the point 0, c. Because remember, y-intercept is where x equals 0, and then this will be c. And the reason why it's going to be c is because if x is 0, we end up not having a times 0 is 0, b times 0 is 0, so we're left with just c. So that would be our y-intercept. Now let's talk about graphing this equation. The first thing you want to do is figure out what a, b, and c are. Okay, a is going to be 1/2, b is going to be 4, c is going to be 5. Now in this situation everything is positive, but just remember, notice if you had a negative or a minus sign right here, then b would be -4. Okay, so just keep that in mind. First we find the x of the vertex. Okay, and remember it's -b over 2a. So you see up on top here, I've got negative 4, okay, opposite of b, over 2 times a is 1/2. So that's going to give us negative 4 over 1, which is 4. Negative 4. Okay? So x is negative 4. Which also means that our axis of symmetry is going to be at x equals negative 4. Okay? I'm going to continue to go through some of the things about this graph and then we'll graph it at the end. Okay, so we know that x is negative 4, which puts the axis of symmetry at negative 4, and we'll talk more about that when we get to the graph. The next thing you want to do is you want to find the y of the vertex. And to find the y of the vertex, we plug the x of the vertex into the equation. So what you'll see here, what I did was I put negative 4 in for the x's. Okay, negative 4 in for the x's. And when you work that out, you're going to end up with 8 plus negative 16 plus 5, and that's going to equal negative 3. So that means that our vertex is at the point negative 4, negative 3. And then we have one other thing that we need to talk about, and that would be the y-intercept. For this problem, the y-intercept is going to be at 0, 5. And the reason I know that is because the y-intercept is going to be at c. And since c is plus 5, that's where my y-intercept is going to fall. Okay, so now let's go back and let's graph some of these things. The first thing I want to graph is the vertex. Okay, we found the vertex at the point negative 4, negative 3. So I'm going to graph that 1, 2, 3, 4, 1, 2, 3. Okay, so there's my point, negative 4, negative 3. Now the other thing I know is the axis of symmetry is at x equals negative 4. So I'm going to plot that line right here at x equals negative 4. And notice I'm making that a dashed line, okay? And the reason why I make that a dashed line is because it's not actually part of the parabola, but it's the axis of symmetry. So it shows us what's going to be the same on both sides. Okay, because a parabola is going to look the same on both sides. If I were to fold it along the axis of symmetry, everything would be the same on both sides. Okay, now the other thing I know that's very beneficial is that the y-intercept is at 0, 5. So I'm going to take that point and plot it 1, 2, 3, 4, 5. There's my y-intercept. Now the cool thing about that is that this is going to be one side of the parabola. Now if the other side of the axis of symmetry has to be a mirror image, since this is 4 away from the axis of symmetry, then I know that I go 1, 2, 3, 4 on the other side, and that's going to give me another point of the parabola. So now I can actually sketch this parabola in. And remember, it's a U shape. Okay? It's not the best looking parabola in the world, but that is what the parabola would look like. And notice, we talked about this parabola should be going up because this right here is a positive number. Okay, so just a quick check at the end. Is my graph going up because A is positive? Yes, it is. Okay, now I do want to talk about one thing before I finish up. Sometimes this y-intercept is a really big number. Okay, like let's say the y-intercept was 29. Well, that wouldn't fit on our graph very nicely. So in that situation, what I would do is think of a graph. You can make a T-chart anytime you want to graph something, okay? Now, I think it's easier to use the formulas that you were given for this. But if I had to make a T-chart, like right here, this is at x equals negative 4. What would happen if you plugged in negative 3 or negative 2? Okay, you'd probably get a point somewhere in here, and then you could graph that point and then do the same thing on the other side. So don't forget that you can still plug in some x's. You can pick any x you want, plug it in, find out what y is, and that's going to be a point on the graph. So if your y-intercept is way too big and it falls off the graph, way too big or way too small if it's negative, then don't be afraid to plug in a point. And I would always plug an x in that's close to the axis of symmetry. Then you know it's going to be easier to actually, it's going to be closer and it's not going to be as much off the graph. Okay? So just keep that in mind. And that concludes this section of 4.1, 4.2.